Hello everyone, there are three parts to this video, so it'll be broken into three different videos. Now for this one, we are going to first start discussing about the heat sink, which is the very first question of the practice questions in your homework. Now I need to talk about this because some of you actually couldn't really understand what the question is asking, and hence as a result you just give generic responses. Now that is totally unacceptable even at the national exam level. The minute you give generic responses, the examiner knows, and that's where you be penalized. Now first of all, in this diagram here you're given a heat sink, and you're also given additional information like the heat sink absorbs and removes heat. As I underlined there, removes heat. And in a larger scope, it prevents the system from overheating. So when you look at this diagram, okay, the common mistake by many people is that they dive into the question. But what you need to do is to assess this question and figure out what exactly does it mean. Once you get what the diagram is trying to tell you, you more or less have almost solved every question within here. Now when you look at this diagram, what you have is the cooling fan. The cooling fan. Right, so now the normal thing is that we know that when the fan blows at you, it cools you down. Okay, so that's what's very common among everyone. Okay, now but for here, you need to ask yourself this question: how does it blow at the device? Unfortunately, it doesn't blow at the device. I'll come to that later. Next, you have fin-like structures, which is, and this is a flat base. So generally, this is the main part that's made of aluminum, as stated in the question. Right? And a flat base, and I'm going to illustrate here, this is where your device is. This is where your device is. The heatsink is placed on top of your electronic device. Now, without even looking any further, so how does this whole structure keep this device cool? Now, the device you're mentioning here is usually a central processing unit, but you don't have to know that. All you have to know is a device. The fin-like structures, so these are the fins. I'll just color them in orange. This is a fin, this is another fin, another fin, another fin. Right? So the black gaps there are actually, the dark color gaps there are actually gaps where the air can flow through. Okay? So when the air flows through, it helps to draw the heat away from the heat sink. Alright, it draws away the heat away from the heat sink, and in this case, the cooling fan doesn't blow into the heat sink, but it does the opposite. It blows out of the heat sink, it blows upwards. So in a way that when the air gets heated, immediately the fan sucks the hot air out very quickly. And in doing so, cool air will just keep rushing into the fin-like structures to keep replacing the hot air that has been drawn out by the cooling fan. And once the cool air goes in, it gets heated by the heat sink. So can you see that in this way, as the cool air just keeps coming into the fin-like structures and it becomes hot and then gets drawn out by the cooling fan, in this way it helps to keep continuous flow of cool air into the heat sink. Now, once you establish how this thing works, let's dive into the question. Suggest why a heat sink is usually made of aluminum. Now, the question states that the heat sink is a device that removes heat, so the system cannot overheat. To answer this question, you need to explain how the heat is removed from the system. Now we know that the heat sink is made of aluminum, as already stated here, is aluminum. And aluminum is a metal, so that makes aluminum a good conductor of heat, right? And being a good conductor of heat, it conducts heat away from the device very quickly. Many of you got this wrong because you loosely interchange the terms used in conduction with the terms used in radiation. Now, for example, let me show you this common mistake. You can tell me that aluminum is a good conductor of heat, and then you use the word absorbs. It absorbs heat quickly. Absorb. This term is used in radiation. So when you use the term absorbs, you're referring to radiation. You're no longer referring to conduction. So this reflects a lack of understanding what conduction and radiation means, so leading to confusion. In other words, you need to get your idea of conduction and radiation very clear. You need to distinguish between them very, very clearly. Now, explain why the fin-like structures enable the heat sink to transfer heat faster. Half of you are able to tell me the fin-like structure increases the surface area, but there's another half was unable to understand what exactly the fin-like structure is. So I'm going to try to draw on this slide here what a fin-like structure is. Now, given this is a flat base, right? So if I have this flat base and I need it to, I need this flat base to lose heat fast, the heat can be radiated out in this sense. Heat radiated out in this sense. So it's one flat surface, heat radiates out. Now, how do I increase the area? So all I have is, let's say I have another protrusion here, extended out. Right, give me a while. Let me get rid of all the unnecessary drawings first. So can you see that, first of all, my surface area, instead of the flat surface, has additional surface here and on the other side. So this surface and the vertical surface. So the more fins I have, the more vertical surface I have, I'm trying increasing the surface area for radiation, for the rate of heat loss to increase by radiation. So that's what it meant by increase in surface area when it's a fin-like structure. And explain how the air currents above the heatsink enable heat to be transferred away. Now over here, many of you could not really understand the purpose of cooling fan as I mentioned earlier on. So as I've already mentioned earlier on, you need to understand how the cooling fan works before we understand how the heatsink helps to keep the device cool. Right? So I already explained this earlier on in my video. I'm just going to push on to the next question. A student suggests painting the heatsink black. So suggest a possible reason for this suggestion. Okay, the fact that they really tell you black surface. So that should intuitively tell you that it's actually a good emitter of radiation, because black surface and, remember the original question, remove heat, and hence it has to be a good emitter of radiation to increase the rate of heat loss by radiation. Now, again, those of you who got this wrong are confused between conduction and radiation. Okay, and another group that got this wrong actually stated two facts that doesn't really answer the question. You stated that the black surface is a good emitter and a good absorber of radiation. So this is what I call stating two technically correct statements, but didn't really answer what the question is asking. How does it being a good absorber allows it to remove heat. You're just absorbing the heat and keeping the heat there, right? So it doesn't really work that way, okay? So another thing you also have to note that when they say black surface is a good emitter and good absorber of radiation, this is mainly what many textbooks write. Okay, so you cannot just take this information and throw it in and expect the reader to understand what you're trying to say, right? It doesn't really explain the question. Okay, so what you're trying to say is that the inner surface, the surface below the heatsink that's in contact with the device, is painted black, is a good absorber because you want to absorb heat from the device fast. And then the upper surface, which is facing the fan, has to be a good emitter of radiation because you want to increase the rate of heat loss by radiation. So you got to be very specific which part is a good emitter, which part is a good absorber, rather than just blindly stating from the textbook.